Hi, and today we're going to talk about our second lesson in the center and spread section. And today we're going to be introducing that very important concept in statistics, the standard deviation. By definition, standard deviation represents the average, and I'm going to put that in quotes, the average distance any one data point is from the mean. So there is a definition for the term standard deviation, at least in layman's terms. It's the quote-unquote average distance that any one data point is from the mean of the data set. And you can see I have the ages of the CLIO teachers up there again, the totally made-up data. And this time I want to select 6 of them at random. You can see that I have programmed my calculator to do that. There were 28 ages shown. So I chose integer from the math and number menus, then 28 times rand, and rand is found in math and probability, then add 1. The adding 1 tells you that you're starting with the first data value. You need 28 values starting with 1 because there were 28 ages. And it so happens that the first one I got was the first teacher, who was 23 years old, a little bit bigger. Dot at 23. The 16th age, well, I know that there are 14, so there's 15. 16th is the 36, and that's going to be right about in here. The 24th, oh, there are 28, 27, 26, 25, 24 is 49 years old. And I need 3 more. I want to get 6 ages here. The 28th, oh, that's the 56-year-old. And one more time, number 8. Now, if we had gotten any repeats, we would have to ignore repeats and select another because you can't use the same person twice. 1, 2, 3, 4, 5, 6, 7, 8. 26-year-old. One more. And, whoops, number 8. We cannot use you. We already had you. Number 4. So 25-year-old. All right. Boy, our ages just got cluttered down there at the low end, didn't they? A bunch of them down there. All right, so what we'd like to do is think about finding the standard deviation of this data set. And I picked 6 of these ages at random just so we would have some numbers to work with. You can see that I've transferred the data from our previous screen here. We selected employee 1, 4, 8, etc. and their respective ages I put into this table. We are going to find the standard deviation of this small data set using the table that you see in front of you. The differences from the mean, that is x minus x bar. If x is a data point, x bar is the mean. That's the way our calculator talks about it, and we will call it that as well. X bar is the mean. Those differences are called deviations. And of course, we want to find the standard deviation, that is the average distance that any one of the ages is from the mean. That's what the standard deviation represents. Okay, before we do that, we've got to find the average. And that means we've got to add up our ages and then divide by 6 because we had 6 work groups. 23 plus 25 plus 26 plus 36 plus 49 plus 56, all divided by 6 because we had 6 teachers represented. All right, let's see what that is. 35.8. So for our data set, our mean is 35.8 approximately. So I should probably have squiggles instead of an equals. Okay, the formula for standard deviation, which is known as lowercase s, is equal to, and folks, it starts out with a great big square root. What's under the square root is this. It's the summation of, that squiggly e stands for summation. It's the sum of all the x minus x bar pairs raised to the second power divided by n minus 1, where n is the sample size. Our sample size is 6 because we had 6 teachers. X represents a data value, or an age in this case. X bar is the mean of the data set, which we know is 35.8. And this formula looks awful, but it's really not so bad, especially when you break it up into pieces like this. So we're going to take each age and we are going to subtract 35.8 from it. Then we're going to square. The square is what has to be added, so I very often do that to my data table so that I can see what I'm doing. And let's see if we can't get started. So I'm going to clear off my calculator and I'm going to try and be very careful here. 23 minus 35.8 is negative 12.8, which of course is under the mean. This person was 12 years younger, almost 13 years younger than the mean. We square to get rid of that difference. So I'm going to go ahead and square that right now. And we're talking 163.84. I'm going to continue filling in the table. I just won't talk as much. Negative 10.8, and we want that squared. 116.64. 26 is our next person. Take away the average. 9.8 years under. 9604. 36. Finally, we're going to get somebody above the mean, only by 2/10. Squaring that, 0.04. 49 minus mean is 13.2. And that needs to be squared. 174.24. And our oldest worker we got 35.8. That's 20.2. And squaring, so put it around 400. Yeah, 40804. All right, we have our table filled in. All that's left now is to apply the formula. And we've got the x minus x bar squared. The summing is what comes next. So we have to add up this column. We have the 408.04. Okay, so I want to add that to 174.24 plus 0.04 plus 96.04 plus 116.64 plus 163.84. All right, there's the sum. 958.84. And that was right. Going back to the formula, our summation is 958.84. That gets divided by n minus 1. N is the number of cases. We had 6 in our sample, so we are dividing by 5. I'm going to go ahead and do that here. It means we're talking about the square root of 191.768. And before I take the square root, I want to mention the square of the standard deviation. That's the number we're looking at right here before you take the square root. That is called the variance, and it is another measure of spread that's often cited. So you will hear us talk about the variance. That means before you take the square root of the standard deviation. For us, the variance is then 191.768. Our standard deviation will be the square root of that, and the square root of our variance is around 13.8. So squiggly lines here. We're not exact, but we're around 13.85 if we went to the nearest 100. All right, that looks like a lot of work, and I will say that is a lot of work. The good news is that once you've done it by hand a couple of times, you don't need to do it anymore. You can find that in your one variable statistics. It's called S of X, SX. S for standard deviation of a sample. Let's go test that and see if it's true. Here come our list of ages. We had 23, 25, 26, 36, 49, and 56. And I said it should be in the one variable stats, so stat, calc, one variable stats, in list 1, so we're good. Cha-ching! There's the average. We got that right. Standard deviation 13.85. Hey, you guys, this is good news for us. If we've done it by table once, now we can do it by calc. Here's a little test of our comprehension, really. Do we get what standard deviation is? They want us to match up a data set with a possible standard deviation. And I would love you to stop this video right now and see if you agree with me. I will see you in just a moment. All right, as I look at this data set, all of the data values are the same. If standard deviation measures the average distance a data value is from the mean, then this one must be the 0, because there is no difference between these data items. The mean is 1 and they are all 1. The next data set, 1, 2, 3, 4, 5, has more variation, right? It has a larger range of numbers it's covering than this one, 1, 2, and 2. The standard deviation of this, if it has a larger range, has got to be the bigger number. Folks, that one goes with the standard deviation 1.581, and you could check that out with your calculator. This guy, his standard deviation is going to be low because there's not a whole lot of variation in the numbers in the set. So 0.577 works for that one. Just a little bit of, do we understand what standard deviation is really saying? And I'll bet right about this point some of you are thinking, no, I don't. But we'll get used to it and we'll do better. Our last topic today is finding the mean and standard deviation for a frequency table, folks. This is a bit different. It uses the same style of thinking. And I'm going to talk about this example as I'm explaining. We have, it says 5 pennies, 4 nickels, and 2 quarters. 5 pennies, 4 nickels, 2 quarters. The value of those coins, that's the X in this problem. A penny is worth 1 cent, a nickel 5 cents, and of course a quarter 25 cents. To find the mean of this frequency table, the thinking is similar, okay? We take the summation of each XF pair. If you think about what that means, folks, and then divide by the number of coins that there are. If you think about what that means, we want the total value. Okay, we're going to find the total value of our coins and then the average of that. So the average value per coin. XF. So the value of a penny is 1 cent. We had 5 of them, so that's 1 times 5, 5. 5 cents for a nickel, and we had 4 of them, so that's 20 cents. 25 cents for a quarter times 2 quarters, 50 cents. That is a total of 75 cents in value over 11 coins. So for us, the average value in this frequency table is 75 over 11, which is about, well, it's close to 7. 6.818, I'm going to go. And I will have done a little bit of rounding here, but I think it will be okay. Now, finding the standard deviation from this point on is not a whole lot different. We know that the x bar is 6.818. And the formula for standard deviation in a frequency table is just like the other with one exception. It calls for a summation of all the x minus x bar squared pairs, but you have several of those deviations. In fact, you have f of them if f stands for the frequency. That is then divided by n minus 1, and in this case n is equal to 11. Alright, so there's a formula for standard deviation. Again, it doesn't look a whole lot different. Will work a lot alike. I'm going to do the work for this, and I will catch up with you in just a moment. I'm going to start by taking an x value of 1. I'm going to subtract the mean, which was 6.818. So I'll show you one row, and then I'll skip to the bottom. 5.818. I need that squared and multiplied by the number of pennies that I had. That's the deviation of 1 penny from the mean. I had 5 of them. So I'm going to square and then multiply by 5 pennies. And I have 169,24562. All right, I have my deviations all in, squared times frequency. Now comes this part of the formula where I want to add. So I'm going to take this column and add those numbers together. I'm taking it out to quite a bit of precision. I don't want to lose precision if I can help it. So I'm taking it out to like 5 decimal places. And if I type everything right, that is 843.63637. I'm looking at the formula. I do have the sum, so I have the top of it. I next need to divide by 1 less than the number of coins, and that's 10 for us. So I shouldn't need a calculator to divide by 10. But just to show you, what we have right here, so 84.36 approximately, is the variance of this data set. Remember, variance is before you take the square root. So this number came right from there. To find the standard deviation, I need the square root of 84.36, and I'm going to do that here. Root of the answer, about 9.18 roughly. Okay, I guess I'd let the cat out of the bag. You know, that was a lot of work to get that. And it says here, folks, that we could do that in our calculator, which I hope you will from now on. I swear that's the last time I'll make you do a standard deviation by hand. But let's check it and see if it's right. I have put into my list the x values, that's the value of each coin, and the number of each of those coins I have in list 2. So here's the x, here's the f. And this says that I do one variable stats, which I know is in stat, and over to calc and choose one variable. My x list is list 1. But this time, folks, my frequencies are in list 2. And second and 2 is what will get you that. Then it's calculate. And let's see. Oh, my word. Did you see how fast that was? And there's that 9.18. Same thing that we got. Way shorter. I hope that you'll remember that and learn to love it. I do. And please go out there and try that. You try tonight. And we'll talk more about the standard deviation in class tomorrow.